Yeah, guys, welcome once again to our revision course videos on series. In this part, we'll be starting off with geometric progression. In the previous video, we saw how we worked through the arithmetic progression. We explained all the concepts that were clear for your understanding. So many questions were also solved, and we went through them to help you to appreciate how the APs work. In this part, we'll be focusing on geometric progression. I'm sure that if you are familiar with Learn West Africa, going through our regular course on additional mathematics on geometric progression, we've had an extensive discussion of the geometric progression. This course or this section is not designed to take you to everything on geometric progression. No. The key component of what we're going to do here is to look at the important features of a geometric progression and how all those things could be tested in an exam. So I hope that you just pay attention here and let's get the couple of things. To just start with, we know geometric progression to mean that any kind of progression or sequence where, unlike the AP, it has a ratio, a common ratio. That is, there is a multiplier that is always attached to each term and it goes into the other term. That is what we refer to as a geometric progression. So whereas in an AP, you would have a constant number being added to the successive terms to generate successive terms. In geometric progression, we multiply to generate those terms. Now, the number that we use in multiplying to generate those terms in geometric progression, we call it the common ratio, okay? And the first term is also mostly referred to as A in the exam. Mind you, for purpose of examination, you may not always have the common ratio and the first term being described as A or R. A could be anything else. Remember, it's only conventional that mathematicians choose A for the first term. But in real exam, it's possible that the A could be changed into another letter. So just watch out so that you don't get confused. You could have a geometric progression where the first term will be described as K. The first term could be described as M, T, any letter at all. All these are just variables. The first concept that we just want to remember is that for any geometric progression, any term in it, each future term Tn is given by A raised to the power R, AR to the power n minus 1, okay? AR to the power n minus 1, where the n refers to the term that we want, and the first term is known as A, and your R is your common difference. So just get that. So if you have, we want to find the third term, then it means that you're going to use T3. You slot in the values there, and you get your answer. All right. Then we also have what we call the sum of terms of a geometric progression. The sum of terms of a geometric progression. When you have a geometric sequence, there are times that you may want to find the sum of a particular set of terms in the sequence. How do we find that? Now, the sum of the terms is given by Sn, A into bracket, R to the power n minus 1. Please watch the difference in the way the sum is represented. Okay? The future term or the nth term in the geometric progression is A, R, all to the power n minus 1. So the minus 1 is attached in an exponent form when you want a particular term. But when we have the sum case, the scenario where we want to find the sum of a geometric progression, the 1 does not exist as an exponent. Please keep that. It is R to the power n, the n is exponent, minus 1 all over 1 minus R. Another point to note that we use this sum when your common ratio is more than 1. So sometimes we say that the absolute value of R is greater than 1. Okay? Where your R is more than 1. Okay? So if the common ratio is greater than 1, this is how you will find the sum of the number of terms. However, if the common ratio is less than 1, if the common ratio is less than 1, Sn, you are going to write A into bracket 1 minus R to the power n closed 1 minus R. Hope you're okay with that. So watch the difference. When your common ratio is greater than 1, your R comes first. However, if the common ratio R is less than 1, the 1 will come first. So note the difference. Anytime you have a geometric progression and you see the common ratio be more than 1 or less than 1, it's important to note which of the instance that you have to choose to find them. Then we come to the last part of a geometric progression, we are referring to the sum to infinity. Sum to infinity. Remember, when we say sum to infinity, it is what exists, or it is the sum of a geometric progression when the sequence or the series is convergent. When we say convergent, what do we mean? Convergent means that as the sequence goes on and on and on, it gets to a point where you realize that the change is not so significant. And this will only happen when your common ratio is less than 1. That is, the divisive or the multiplier effect is less than 1, which means that it does not increase so much. So as the sequence goes along the line, you realize that the whole geometric sequence could be reduced to a whole number. We say that that sequence is convergent. For that purpose, we could find a sum to infinity. There will not exist a sum to infinity if the common ratio is more than 1. Because once the common ratio is more than 1, or is positive, larger, then it means that as you go along the progression, the geometric progression is going to get huge. Like you have 2, 6, 18. The common ratio is 3. So as you have 3 being multiplied by 18, it's going to get huge, and that will go to a very large number. It will be very difficult for you to sum such a sequence to infinity. Its sum to infinity will be infinity. But the sum to infinity, as you find in your level, is where the common ratio is less than 1. The sum to infinity is giving us a all over 1 minus r. So remember, there are 2 things that you need just to find the sum to infinity: your first term and your common ratio. Once you know your first term and the common ratio, the sum to infinity of a geometric sequence or progression should be done and dusted. So these are the 3 main points that have to be covered under geometric progression. Going into your exam, remember the term of a GP, the sum of terms. In the event where the common ratio is greater than 1, in the event where the common ratio is less than 1, and also when the common ratio is less than 1, it's sum to infinity. In another sense, we can say that the point at which the sum or the series or sequence converges. Join me as we look through the following examples to illustrate all these points that we have discussed.